welcome to this video on what is currently the second lesson in the Human Body Part 2 scheme, and certainly the first lesson in the series of lessons on diseases. And this is one of our historical case study lessons that we have throughout the GLT curriculum. And the purpose of this one is to introduce students to the really important concept that runs through the whole of the series of lessons on diseases, which is this idea of pathogens. And really, we're calling it germ theory because that's what it was called in the early days. It's this idea that there's something from the outside which is getting into our bodies, and that's what's causing disease. And to us, it seems like it's something so obvious that we can't see how anyone would think otherwise. But actually, this was a subject of much controversy for many centuries. And what we're going to do in this lesson is show students two rival theories and some experiments that were done that ultimately decided in favour of the germ theory of disease. So the two rival theories we're going to look at, I'm going to start by drawing this. I'll draw it quite simply here. So I'm going to draw a stick person or kind of gingerbread person like this. So one theory of disease goes something like this, that actually the reason we get sick, let me just focus that, hopefully that will become clearer. The reason we get sick is because there's changes happening inside our body. So something happens inside our body, and then that change somehow spreads outwards, and we start to feel ill. And that's a fairly plausible explanation because, you know, you can ask students about this when they get sick, if they get a cold or whatever, if they have COVID, anything like that. It's not like you really notice anything happening. You feel well. Next thing you know, you're starting to feel a bit ill, and then you feel iller and iller and iller, and you really have no idea what's going on. So this is a really plausible theory. This theory that it happens inside your bodies and there's no real kind of precursor to that, this is the theory of spontaneous generation. Now, to be honest, the words spontaneous generation aren't that important. What's important is the fundamental idea that the old way of thinking about disease before, well, we're going to talk about Pasteur mainly, but yeah, so let's say before Pasteur for now, was that disease was caused by changes inside your body. There's not this idea that there's something coming from the outside and getting in. And this is where we're going to compare this with Pasteur's theory. So if I draw my same gingerbread person again, very large shoulder. Well, the germ theory of disease says something different. It says actually what causes disease is something from the outside that gets in. And then there's this kind of ripple effect from there where this germ, as we're going to call it here, this germ that gets inside is what causes disease to then spread inside your body. And this is the germ theory. And what we're going to do in this lesson is compare and contrast these two theories. We're going to look at some experiments that were done and show why we as scientists are obliged not to believe this one, but we're obliged to believe this one. This gives us the best account of the available evidence. So the first experiment we're going to look at, I'm going to say all of these experiments were done by Louis Pasteur. I think Louis Pasteur is a really important person for students to know about. Certainly, he was the one who gave the decisive evidence in favour of the germ theory. The first experiment I'm going to talk about actually happened about 300 years before Pasteur, but this is not a history lesson, this is a science lesson. So we're going to neglect historical accuracy, and we're just going to say Pasteur did this experiment. And what Pasteur noticed was that if you leave meat out on a hot day, and it's super hot here where I am, it's about 32 degrees here, so you can imagine Pasteur somewhere in France on a really hot day like this. He noticed that if he left meat out or on his, I don't know, his kitchen table or wherever, it started to gather flies, and he even noticed these little kind of eggs, which were actually pupae. But he noticed that these flies gathered, and then the meat started to go bad, and it became smelly, maybe it discoloured or whatever. Now, the people who believed in spontaneous generation, they would have said the reason the meat is going bad is because something inside the meat is changing the rest of the meat, and that's what's making it go bad. And Pasteur said, no, actually, what's happening is the flies that are landing on the meat, they're what are causing it. So what he did was devise a really simple experiment, which we're going to draw out here. So we had two glass boxes, both with the lids off for the time being. And what he did is he put, I'm just going to move this down here, he put a piece of meat inside each box. So I'm just going to draw something really simple like this. And I don't think I need to label this. I think students will be able to follow if you're talking them through the story like I am here. And what he did was, with one of these pieces of meat, he put the lid on the box, and with the other, he left the lid off. And it's important that he did this, and you can draw students' attention to this. This is what we would call a control experiment, because what he's really interested in is what's happening inside the second box. But he has to do the control experiment just to show that with a similar piece of meat, something different would have happened when he didn't put the lid on. So he wanted to show that it was putting the lid on that had the impact on what happened to the piece of meat. And again, as you will know, that ties into control variables and all that stuff, and this is a really nice way of introducing that sort of idea. So what we want to do then is think, okay, let's say spontaneous generation was true. What would we expect to happen in that case? So what I'm going to do, I'm going to draw a little bracket like this, and I'm going to draw a line down here. So let's imagine spontaneous generation, this theory was true. What would we expect to happen? And what we're doing here is really reinforcing with students this idea of guess, deduce, check. So if spontaneous generation is our guess, here we're now deducing what we'd expect to happen. Well, what we'd expect to happen in each case is that some sort of change happens on the inside, that then spreads throughout the piece of meat. Both cases, it doesn't matter whether the lid's on or off, what's happening is happening inside the meat. So in both cases, what we'd expect is that regardless of whether the lid is on or not, this meat goes bad, gets smelly, maybe discoloured. Same in there as well. That's what we'd expect to happen if spontaneous generation was true. What about if the germ theory was true? What would we expect to happen? Well, this picture would look slightly different. So in the first case, right like that, well, what we'd expect to happen is that these flies that Pasteur had noticed, let's draw a few flies on here. So these flies would land, they'd lay their eggs somehow like this. Well, they're really pupae that you saw, but whatever. And ultimately, because of these germs that Pasteur was thinking about would get into the meat. And so in this case, the meat would go bad. But in the example, the second example, where the lid is on the box, we'd expect something slightly different to happen, because the flies would not be able to land on the meat. So the flies, they'd be sitting up here, might even lay their eggs up there, but there's no way that the pathogens, the germs, let's say, can get into the box. So they're just going to be on the outside of the box, but they're not going to get on the meat. So what Pasteur would have expected to happen is that the sealed box, the meat in the sealed box, I beg your pardon, would not go off. And you can ask your students, well, what do you think did in fact happen? And I would probably do this, I'd maybe label that as number 1, that one is number 2, I'd ask them to show me on their fingers, I'd ask them why, okay, tell me why do you think 1 would happen or 2, and so on. And what do you think Pasteur observed? Well, of course, it was not this one. They didn't both go off. This one went off a lot quicker than this one. Now, if you left this one out long enough, I'm sure this one would start to go off as well. But the main point is that it would last a lot longer if it was sealed than if the box was left open. So this is the first piece of evidence that we're going to give students that this theory presented by, or certainly proved decisively by Pasteur, the germ theory, that this is the best way of explaining why diseases happen. So this is the first piece of evidence, and I'm going to stop this video here, and I'll do another video for the second part of the exposition in this lesson.